Hello good day viewers. In this tutorial we are going to learn how to find the derivative of sine x from the first principle. So the video is going to be a little bit longer because I'm going to show you entirely everything including the squeeze theorem. We are given that if f of x is equal to sine x, what is f prime of x, which is the same thing as dy over dx. So from definition of derivatives from the first principle, dy over dx, or I can simply call it f prime of x, is equal to the limit as h approaches 0 of the function f of x plus h minus f of x divided by h. This is just the definition from the first principle. So let us substitute everything because f of x is equal to sine x. Wherever we have x, we are going to replace it with x plus h here. So this is equal to the limit as h approaches 0 of f of x plus h, that is sine of what? X plus h. The minus f of x is sine x, right? So we have sine x here, then divide by h. This is just the definition. Now I would like to take the whole of this and simplify it before we come back to our limit. So let me drop it down here, simplify. So if we want to expand this, which is sine of x plus h double angles, we have sine of the first angle multiplied by cosine of the second angle, then plus sine of the second angle multiplied by cosine of the first angle. Then don't forget to subtract minus sine x here, right? Then divide by h. We have sine x here, we have sine x here, so you can bring them together. This is equal to sine x cos h. This is not hyperbolic cosine, please. This is cos of h. Then minus sine x, because we are collecting like terms, plus sine h cos x. Don't forget, divide by h. Now since we have sine x in both terms, we can factor it out. So we have sine x outside, then inside we have cos h minus 1, right? Then plus sine h cos x whole divided by h. We are moving. We have not finished simplifying yet, but now we can split the fractions. We have sine x, then cos h minus 1. I want to divide this by h, then plus. You know, this is the expression that contains h, so I would like to divide it by h. So we have cos x multiplied by sine h divided by h. We cannot apply limit yet because the moment you substitute 0 here, because h is approaching 0, and this will be 0 over 0 situation because sine of 0 is 0 and h is 0. So we have an indeterminate expression. So let's continue simplifying. I would like to multiply the top and the bottom of this by the conjugate of cos h minus 1, which is just cos h plus 1. So this is equal to sine x multiplied by cos h minus 1 times cos h plus 1 divided by h multiplied by cos h plus 1. I just multiply the top and the bottom by cos h plus 1. Then we have plus cos x sine h divided by h. If you observe, this is nothing but difference of two squares. You take the first time, you square that, that is cos squared h. So we have sine x multiplied by cos squared h minus the second time squared, that is 1 squared is 1. We divide by h multiplied by cos h plus 1. Then we still have plus cos x sine h divided by h. We have a bracket here. And you should remember that sine squared h plus cosine squared h is equal to 1, and therefore 1 minus cosine squared h will be equal to sine squared h, right? So therefore, let us factor out -1 from here so that we can make the expression accurate. So this is equal to, if you factor out -1 here, you multiply by sine x. Inside the bracket, you have 1 minus cos squared h divided by h times cos h plus 1, then plus cos x sine h divided by h. And 1 minus cos squared h is nothing but sine squared h. So this is equal to negative sine x multiplied by sine squared h divided by h times cos h plus 1, then plus cos x sine h divided by h. We can split this, right? This is equal to, already we have negative sine x multiplied by, we can have sine squared h is the same thing as sine h times sine h. So we have sine h divided by one of the h, because we have h here, multiplied by another sine h divided by cos h plus 1. Then we have plus cos x multiplied by sine h divided by h. So from here, I think we can apply our limit on every single expression. And you should know that the limit is only going to affect those expressions that contain h, because the limit is what? At h approaches 0, so it has nothing to do with x. So we're going to take the limit here. So negative sine x is out because it has nothing to do with the limit. We are going to consider it as constant, and limit of a constant is still the constant. So we take the limit as h approaches 0 of the first expression, which is sine h over h. Then you multiply, you take the limit again as h approaches 0 of the second expression, which is sine h over cos h plus 1. And then we have plus cos x, because it has nothing to do with the limit, multiplied by the limit as h approaches 0 of sine h over h. All right, now you should observe something. We can directly substitute our limit here, but we cannot do that here and here. Why? Because if h is 0, we have sine 0, which is 0 over 0, which is indeterminate. But sine h, which is 0, is 0. That is sine 0 is 0. And cos 0 is 1. 1 plus 1 is 2. So we have 0 divided by 2, which is still 0. So the whole of this is 0, right? This is equal to sine x multiplied by the limit as h approaches 0 of sine h over h. Then multiply by, I can substitute here, we have sine 0 to the top, divide by cos 0 plus 1. Then plus cosine x multiplied by the limit as h approaches 0 of sine h over h. So you can see that sine 0 is 0, cosine 0 is 1, plus 1 is 2. So to the top we have 0 divided by 2, which is 0. So if you take this 0 and multiply by the whole of this, you are going to get 0. So the only limit we need to simplify is this. But since we have another one here, we can simplify altogether and substitute. Though we know that this cannot be equal to 0, right? Because h cannot be equal to 0. So now we are going to apply squeeze theorem to find the limit as h approaches 0 of the function sine h divided by h. And the mother of trigonometry is unicycle, so we are going to use unicycle. All right, here we have a unicycle. Why we call it unicycle is because the distance from the center of the cycle to every part of the circumference is equal to 1 unit. So this is a unicycle. So what are we going to do? First of all, I would like to draw a tangent line here. A tangent line is a line that touches the cycle at exactly 1 point. I can even extend it if I like. This is a tangent line because it touches the cycle at exactly 1 point. So from this point here, I would like to connect it with this center. This is going to be an angle, which is h in this case. I would like to connect this point down to this point. So the first thing I would like to do is to find the area of this triangle. You can see that here. This small triangle, I would like to find its area. And how can we do that? You know, area of triangle is half the base times the height. So what will be the height? This is going to be our height, which is the opposite to our angle. I remember that the hypotenuse is 1 unit because from the center to every point on the circumference is 1 unit. So how can we find the opposite side, which is going to be the height of this triangle? Sine h is equal to what? Opposite, that is the side we are looking for, divided by the hypotenuse, which is 1. So you can make opposite the subject by cross multiplication. You can see that opposite is equal to what? Sine h. Therefore, this is what? Sine h. The height is sine h. And the base from the center to the circumference is also 1 unit. So the base is also 1 unit. So let's find the area of that triangle. Though I can name it, let me call it, this is O. Let's call this point A. Let's call this point B, right? So the triangle there has the area half. The base is 1. The height is what? Sine h. Secondly, I would like to find the area of sector. You can see we have a sector here. This is a sector. The whole of this is a sector. And it must be, the area of that sector must be greater than area of the initial triangle because we have added a piece. This small piece we have added to the triangle to make it a sector. So what is the area of sector? So this is less than or equal to the area of that sector, which is 1 over 2. R squared, that is 1 squared. Theta, which is what? H. Then lastly, I would like to find the area of the entire figure here, this big triangle. This big triangle, we would like to find its area. You should know that it is equally half the base times the height. The height is this point, which is just the tangent. Remember, it is the tangent h. So half the base is 1 times the tangent. So it must be less than or equal to the area of the big triangle, which is half the base is 1, the height is the tangent h. So let's simplify everything here. Remember, we are looking for the limit as what? As h approaches 0 of sine h divided by h. So we are establishing a relationship that will give us sine h divided by h here. 1 over 2 times 1 is still 1 over 2 times sine h will give us sine h divided by 2 less than or equal to 1 squared is 1 times half is half times h is h divided by 2 less than or equal to half times 1 is half multiplied by tangent h, that is tangent h divided by 2. So we can multiply every single term by 2 just to clear the fractions. So you can see that sine h is less than or equal to h less than or equal to tangent h, which is the same thing as sine h, divided by cosine h. You should know that. Cosine h. From here, we can divide every single term by sine h. So we have this divided by sine h this divide by sine h, this also divide by sine h, or simply by multiplying by the reciprocal of sine h, multiplied by 1 divided by sine h. It's all the same, right? So this will be 1 because they are exactly the same. We have 1 less than or equal to h divided by sine h less than or equal to sine h will cancel sine h, so we have 1 over cosine h. So we are going to take a reciprocal of every single term here because we have started establishing what we want. You know, we are looking for sine h over h, not h over sine h. So reciprocal of 1 is 1. And by taking reciprocal, the sign of the inequality will change. So we have sine h divided by h greater or equal to cosine h. So we can reflect the inequality by writing this one before this. So we have cos h less than or equal to sine h divided by h less than or equal to 1. So from here we can take the limit of every single term. But before we take the limit, let me remind you what the squeeze theorem stated. It stated that if you have three functions, f of x, g of x, and h of x, three functions, and it happens that the limit of the first one here, the limit of the first one as x approaches a, for example, is equal to L, and the last one, the limit as x approaches a again is equal to L, and it happens that this g of x is less than h of x but greater than f of x, and the limit of this approaches L, the limit of this approaches L, and we know that this and this has the same limit. It implies that the limit as x approaches a of this g of x must also be equal to L. So look at it carefully. This function is greater than this one but less than this one. But it happens that the limit of this is equal to the limit of the last one. It implies that the limit of the middle function, which has been squeezed between the two functions, must be equal to their respective limits. So that is what we are going to evaluate here and see. But the limit of this must be equal to the limit of this for that statement to be true. So let's find out. You should know that this is a constant. A limit of a constant is constant. So what limit are we taking as h approaches 0? So we take the limit as h approaches 0 of cos h less than or equal to the limit as h approaches 0 of sine h divided by h less than or equal to the limit as h approaches 0 of this constant 1. I told you limit of constant is constant, so let me finish with this one. It must remain constant, and we are looking for this one, so we repeat it. Limit as h approaches 0 of sine h over h. So if you substitute 0 in here, you're going to obtain cos 0, and cos 0 is equal to 1. So you can see that this function has been squeezed in between 1 to 1, and hence we conclude that the limit as h approaches 0 of the function sine h divided by h must also be equal to 1. So we are going to substitute this into our problem here. So this is equal to sine x multiplied by the whole of this is equal to 1 multiplied by 1 multiplied by this is 0 multiplied by 0, then plus cosine x multiplied by this, which we have just obtained, is 1. So you can see that the whole of this will give us 0. We have 0 plus this times 1 is cos x, and finally 0 plus cos x is equal to cos x. So therefore we conclude that the derivative with respect to x of the function sine x is nothing but cos x. As simple as that for the first principle. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.